So before we start, what we're going to show is some scripting and way we interact with things. Sometimes in order to save us time and me writing a lot of bugs, we're just going to copy some example code that we have. And you can find this code in the OMFIT tutorial module. So either by importing the tutorial module in OMFIT, which is what I will do, or even online, if you go under develop, this page pops up, and then under tutorial module, you'll see the set of, here, and then these tutorials, which is browsable online. And these are kind of some sample scripts that you can, look to kind of learn how to do things either in OMFIT or in Python. One more thing that Sterling was pointing out was that all of the plotting that we're doing, certainly the one that we're going to see today, is done in matplotlib. Which is this Python library for plotting. And so if you go to matplotlib.org, they have actually some very good examples on how to do plotting for all kinds of different things, interactive plots or scatter plots, line plots, and so on and so forth. So this is also a very good resource. And everything that we're doing is not rehearsed. So this is, and there's no safety net. So we'll see how this works out. So as I said, let me start by importing the tutorial module. So if we go File, Import Module, and here we're gonna search for a tutorial. So this is the tutorial module. We load it. And so here you can see, a set of scripts, plots, and GUIs that you can play around. The names should be pretty self-descriptive. So today we're going to use this, and one more thing that we're gonna use are some regression scripts. So in OMFIT we have some scripts that we use to make sure that when we change things, functionalities don't get broken. Okay, and these scripts that you can reach them by going under File, and there is this load regression script. And you're going to be already in the right directory, which is the OMFIT source / regression directory. And here you can see that there are a whole bunch of different scripts that do very, very different things. Some script check only maybe some function for math function maybe, like these fit scripts here. Other scripts run entire workflows to make sure that the whole chain of connecting modules together is working right. So for example, if you look at kinetic, this will test an entire kinetic OMFIT workflow for D3D and other machines. And we can also use these as actually examples. I can, for example, load this one to see how you would drive an OMFIT workflow programmatically. So if I push a spacebar, you can see how, for example, here we set some default shot in time, how to load the module programmatically, and for example, here you go through the different iteration of a kinetic OMFIT. Okay, so let's say that you want to do a kinetic OMFIT for 10 different shots. You can use actually this script and call it 10 times by providing the shot different shot numbers. So these are regression scripts, but you can also use them for kind of a template to do more. Okay, so We have few topics that we're going to cover today. The first big set of topic is going to be about plotting. Then we have something about LaTeX that David developed, and he's going to tell us about. Something about the scripting, and then some settings, and various leftover tips and tricks that we don't cover before. So I'm going to go down this order. The first thing that we have here is how to use. So I'm just going to do some things in the plotting area. Okay. So let me load, for example, a G file. I'm going to load a G file. I'm going to look under samples here. Samples. And here I can filter for G file. We can pick something. Okay. G file. Okay. So the first thing that I wanted to show is sometimes you have a figure like this where you have multiple panes, and in OMFIT there is a way that you can look at only one pane at a time. So this is something that, for example, the GA IDL tools can do. You do this by right-clicking on the pane that you want. So I want to see the pressure big. I want to see the equilibrium big. Okay, and you do a middle click to go back to what it was. Sometimes you have all of these tiny plots, and this is helpful. Another thing that we can do with plotting is we can customize this plot without without editing the source code. So this arrow here allows us to select elements in the plot. So if I right-click on an element, you can see that there is a menu. I can select color, and for example, I want to make this red. Okay, we want to make a line width 3. Line style dashed, and change the label, or maybe we want to even change we want to multiply this by 2 and how it looks in the plot. Okay, so this is all things that we can do interactively. When you have multiple things on top of each other, if you hold your right click, it allows you to select what you want. So for example, here we can select a property for the properties for the figure, the axis. There is a polygon, there is a line, and there is the two-dimensional. There is a two-dimensional line. So if I want to change the two-dimensional line to green, maybe I selected the other one. Line to be dashed. Oh, I don't know which one are on top of each other. Anyway, probably if I select this one, see color. Yeah, this one is the other one. M for magenta. Okay. Okay. So once we have this, and actually, there's more that you can do. You can edit if you right-click on a text. You can maybe change the size. You can rotate and so on. Okay. Oops. Rotate 45. And we're gonna also hear more from David about how, if you want to have a consistent style in the way you're plotting things, for example, for a poster or for a publication, how you can use the styles. But that's something that David is going to cover. So let's say that you're happy with this ugly plot. Now, what we want to do, for example, is maybe seeing it as a PDF. Here there are other buttons for, oh yeah, maybe one, more things now that they come to mind. if if you click on a pane, this one becomes the active axis. So this is what the GCA, the get current axis, will return you. So if we do GCA dot plot, I don't know what is the scale on this guy. This is okay. So if we say plot 0, 1, just so that we can have them all on the same 0, 65, for example. This one adds, well, yeah, I didn't do it right, but this one adds the line that we requested there. Okay, if I want to do the same on a different axis, I click on that axis, and when I execute it, I will get that line on that axis. Okay, so this is a way to select the active axis. And you can then use these buttons here to set the X and Y limits. This one shows the legend. So if you click on an axis and you hit this, it will show the axis for sorry, the legend for that axis. Here are some, useful key bindings that you can use. One interesting one is, for example, let me plot something else. Let's plot the pressure. Where is it? Press. If you push L, you will get your plot on a log axis for the Y, and L again for going away from log, and Shift L does it for the X axis. So L and Shift L, this is a log plot, so it's kind of handy to if you want to do that. So once we have this, oh yeah, and maybe one more useful thing, when you're plotting things in OMFIT, if you hit return on an array, you'll get the plot. If you hit shift return, it will overplot. So this is I'm plotting the pressure, and I'm overplotting what P prime. Okay, and again, if I click here and I do this, well, there was, oh yeah, no, there is a legend. Okay, so even if the legend is not shown, you can bring it up this way. Okay, so we have this this plot. If we want to open it in our in our PDF editor, we can click here. This opens it up in XPDF, for example, because I'm in on Linux. You could, for example, print it, save it. I don't know what If you are on Mac OS, it opens it up in preview, so maybe you can annotate it. And another thing that we can do is email it to us. So I'm on Iris. I want to put this figure in my paper. I'm gonna send it to myself. I can write something, and then send it by email. And it should. I'm not gonna open up my mail since we're recording it. Let's see. Oh yeah, there you go. It arrived. Yeah, and in the end, I was able to open it. So this is the PDF that I sent to myself. And you can also send this to other people. It doesn't have to be only your email address. Okay. So now let's save this figure. So here we can save this figure. This is, let me think. Well, let me make it with a nicer figure. Okay, just replotted it. So if we save this figure, we choose a destination for it. Okay, so let's put it under, let's see, I guess slash my home. Yeah. Okay. DMP figure 1 tutorial. Okay. So if we go to that folder, there is a lot of junk, but maybe I should have not put it there. ls figure tutorial. So here you see in this directory that for figure tutorial, we not only have the PDF file, but there's also a H5 file. So I didn't say this, but depending on the extension that you have, you can save your figure in different formats. Okay, these are the supported formats. And whatever format you choose, OMFIT will also save this F5 file. So what is this F5 file? So H5. H5 file. This H5 file, you can look at it as a HDF5 file. So if we go under my home, TMP, come on, and then under right, this one. So the content of this, oh no, this is H5. The content of this H5 file contains your data. Okay, it's organized by axis. We had 5 axes in that figure, and so here it has the arguments that were passed to, for example, a given function. Okay, now the way to open these these files is actually not with the HDF5 format, but with the DMP, which stands for Data Management Plan. These H5 files are written because DOE requires us that whenever we publish something, we have to make the raw data that is in the plot available to the public. Okay, so that's why whenever you save a figure, OMFIT dumps this, and so the data in here is not particularly maybe helpful to be looked at, but the data is there. Also, you can reproduce the original figure by hitting return on that plot. So this, you can see that OMFIT can understand. So this tree structure has both the matplotlib commands and the raw data that went into the plot. So OMFIT can, go execute the same commands on the raw data to that was saved to regenerate exactly that plot.
This is particular to H5 for the data structure.
So DA doesn't specify in what format you should do it. The D3D data management plan says D3D will do it in in H5 files, and there is a website, I think through publications, that requests you give me your H5 file for each one of the figures that you've put in your paper.
Sure, but H5 is so open. The layout of the data is so open.
Oh, sure. Yeah, you could.
The format
produce,
is not. Yeah,
I made some in IDL years ago.
Mm-hmm. Yeah, the format is not. They don't say how you should do it. They just say you should make it available, and someone should be able to open the data. Okay. One thing. Yeah. So now this is one case where I'm going to use the help because I don't remember.
Right. So sorry, just one more thing. So then the H5 files that you actually produce from these plots are only going to be readable through OMFIT.
No, they are H5 files, so anybody can read them.
Well,
They have
sorry.
instructions that are only useful if you load
Right.
them.
If you
In
so
addition to the core data. which is
the
just-
data is stored there, but in addition, it also has the commands to operate on that data, so that OMFIT, or if you are patient, you can write maybe you can write your parser that calls matplotlib
Just gonna try
commands.
to reverse engineer it. And so when you
I mean,
see
it's not
this-
reverse engineering. Like if you see here, the commands that are issued, so for example, the first command is you add the axis. The second command is you call plot, and you pass me this data, and the label was this, and the line width was that. So that's all. It's I think pretty human readable. What's in there. So
I see. So you're embedding matplotlib commands into it to read the data.
well, no, it's just matplotlib commands.
They're
and
just
then
strings.
Just
Right.
strings. It's
Right. You're just putting like a character.
correct.
Right.
It's like a
Correct. Correct.
Are you putting things that are particular to OMFIT?
No.
Okay.
No.
But wait. This is important how you're looking this up.
Oh yeah, well, we already covered this in the previous tutorials, but if you were not here for our previous installments, you can go under Help. We're gonna click under Help window, and this we can use this for lookup for things. In this case, I'm looking for a method for the DMP class, so I'm typing OMFITdmp. And here we can see what are the things that we can do.
But if you've forgotten the exact name, you could have typed in DMP and checked the related tab.
Right. You could also do this DMP, and then under related, it would suggest you things that are related to it.
I don't know about you, but I forget what's going on like every day. So.
So actually, the function that I was looking for is this script. If we go here to the, if we take this object and we call .script on it, and we print it, so this will actually dump a Python script that you can use to regenerate the figure. The other way, so let me bring this up. Control H brings up this OMFIT help window rapidly. If we call this OMFIT Python plot on this object, we're gonna obtain a Python on OMFIT Python plot object. So let's see. I don't know. Plot me. Python plot takes 2 arguments.
New file name.
Oh, the file name. Okay. And so plot me.py. So this is the script. This is auto-generated OMFIT data management plan plotting script. So this is contains it's now a Python file. It contains both the matplotlib instructions and the raw data that you need to generate that same figure. So this is another way. This is actually was inspired by how MATLAB, for example, makes you can generate .m files from figures. Other things going that are interesting. Now, if we go under our tutorial, under plots, there's no view on the. You lied.
That'll happen.
Defer it to when Nick is back.
So, well, actually,
Actually,
we
we
have
will
it
show
in-
the basic and plot a FigureNotebook.
oh yeah, right. So okay. So under the tutorial module, under plots, there is this basic script, which shows very simple, plotting operations. And I'm not gonna annoy you with the basic plots, but there is a FigureNotebook feature that it's pretty useful. So we're gonna copy these two, and so this one we can close. So here we're just creating some data, and then instead of creating a matplotlib figure, we're gonna create this FigureNotebook. We're gonna give a name to the FigureNotebook, and then we can just add different tabs showing different plots. So if we execute this, you see that now you get the same thing, kind of that the plots that we always have, with the addition of this tab. And so with this, you can generate different kind of collate all of your figures together.
When you export that to PDF, it just does that single plot that you're on, or does it
No.
export?
So
the
if
whole
I click on PDF here, it will generate a two-page PDF. And also it will also generate two sine and cosine,
files.
two H5 files for each of the figures. Okay. I think view 1D and view 2D are fun or interesting. What do you think?
Sure.
So I think we can get that from the regression script. What was it? Something about
OMFIT plot.
OMFIT plot. Okay. So Sterling told me that there were view 1D and view 2D scripts, but maybe those didn't get pushed in a stable. So here, I think, do you know what do I need to copy, or it's pretty obvious? So let me search. So
I just search for
find view 1D. Okay. Okay. So I'm just going to execute this, and or maybe shall we go through the code first?
Did you cut it the right way?
I hope so.
Actually, will you move the fake event? This class fake event.
Yeah.
And move that below the other view 1Ds. There's a few more with view 1Ds.
Where? Here?
Yeah, before the view 2D. Yep.
Okay. So if I execute this, you get these well, this is some examples. Okay. I'm gonna simplify some of these. Oh, okay. Still operating. So these are regression scripts. So they're supposed to do to test all kinds of capabilities. Okay. So in OMFIT there are these two classes. The first one called view1D for slicing through a series of 1D data, and the other view2D to kind of interactively slice two-dimensional data. And there's also a view 3D class for looking through a cube of data. So when you are in a view 1D plot, using the right and left arrow keys, you can step through the different snapshot in your series. And with view 2D, you can click and get slices of your data, or you can also select regions and then see the evolution over that region. Okay. Well, I guess it's updating the other one. Okay. And so maybe we can see how this is done. We generate a figure. We generate this is fundamentally three-dimensional data: time, space, and y. And we use this xarray. Xarray is a Python class that is designed to operate on multidimensional structured data. And so here we generate this object, this data array object, where we give it the two-dimensional data. We tell it that the coordinates are space and time, and we give it a name, and then we just feed that multidimensional data to View1D. So if we try to execute only this part of the code, you can see how this looks like. Also, the nice thing about View1D and Xarray is that we gave the name to the data, and then the plotting knows how what are the coordinates, what are the labels that it should use, and so on and so forth. Okay, so maybe I'll pass now oh no, one more thing. Sorry. One more thing that I wanted to show is how we can use OMFIT to interactively edit arrays. So, for example, here we have an array for the pressure. Let's say that we want to modify this array, or maybe to make it a bit more relevant. Let me edit the array for the current. So if we go under the G file, flux surface average, we see this JT over R. So if you right-click on something, you can see several options to interact with the object. Quick plot does the thing that happens when you hit, is what happens when you hit return. Quick overplot, you do that by doing a shift return on the object. And then there are other options for editing. So, for example, I'm going to use a spline editor. So I want to edit this entry. We have to give it, tell it how many control points we're going to use to edit this array. We can say 13. It's kind of a, and so here we see that we see the plot, as it was, and then here we have some control points that we can move around. And I don't know why this is not showing up on Iris.
I went and looked why it's not showing up. It's because the Iris unstable doesn't appear to be updated. You look at your description in the title bar, 1309 should at least be 1350. Blah, blah, blah.
Oh, okay. So, well, this is a bummer, but the data gets updated. It's just that it doesn't show up in real time. But you can if you look here, you can see that the data got indeed updated. And if we if the installation Iris was up to date, that would have occurred. And since we are at it, so you can do this on any one-dimensional array. What I wanted to show was that, for example, you have that current profile. You want to add some bootstrap current at the edge. You would easily go to the edge and add a little bump there to mock that up.
Is it easy to undo?
Right. I should say that. So if you let me take another array. Let's see, P. So if I were there, if you move something here, it's a bit hidden. But if you clicked U, it will undo. If you clicked I, it will insert a node, and D would delete a node. So if I click U, it will reset my line. If I click D, it will delete the control points, and if I click I, it will insert a new control points to the location.
You're not actually overwriting the data.
I'm overwriting the data. if I choose the data and I'm not happy with it, I click U, and then the data gets restored.
But potentially looking.
Yes.
While we're working with 1D arrays, is it possible to show how to like just trim out like a parent data point or something?
How to do what?
Like if just like there's like a 0 or something at the end of an array,
Sure.
just like take it out.
So let's take a Q profile. Okay. Oh, and actually, I'll use this maybe for.
I don't know if you're gonna do that later.
Yeah, it's okay. Questions are super welcome. So here I'm just gonna make this variable called Q, which I'm gonna take from the G file, and to this, well, let me make a copy of it. Okay. And to this, we're gonna add at the last point, we're gonna add a 0. Is that a question?
Oh, never mind. I see. I was wondering if you had a way, like just by right-clicking on it, like in that spline thing that you were gonna like edit.
So well, let me break it. Okay. So now I have an array with the Q. The last point of Q is 0. One thing. So the variables that when you're working here, the variables that you're defining in this space, they're available to you in this command box tab. So these are all the variables that were defined because we were running these other commands. Okay, but Q is the Q that I've defined here. So if I plot this, we should see that indeed the last point is 0. Okay. So to fix that, we can right-click. Probably we don't want to do any of these smooth fixings for something like this. We can do points, and so then we can take this point and drag it down.
Okay, that was the instrument.
And then this
You're
will
touching your data, man.
this will have fixed it.
You should just delete it.
So this would have fixed it.
You made it the value. Delete bad values, not make it what you think you'd like them to be.
Right. With great power comes great responsibility.
Can you
This
delete
is always...
from the quick edit?
No, I don't think. Maybe if you are in edit points, I'm not sure. This is how you get errors. Maybe.
Yeah, delete node. See. D.
Let me see.
The instructions at the bottom would have you delete it, pressing D.
Right. Yeah, it did delete it. So you can delete points, but only if you are in editing points. If you're in editing smooth, it will only edit the control points. Okay.
You might want to replace it with a nan to preserve the length of the array.
Yeah, I mean, yeah. Okay. So, and one more thing that I wanted to show, which may come in handy for people who work with the equilibrium. OMFIT, so an equilibrium file has different arrays. Actually, we can use this. It has an array for the R limiter and Z limiter. And actually, maybe I can use this as an example to combine plots with the X and Y. So here, if we go under plot and say set as X, and we hit return on zlim, you can see that we can see the vessel, right? So the X was taken from rlim and the Y from zlim. We can do the same for RBBS and ZBBS. So if I click on RBBS and I say set this as my X, and I come here, and this time I hit shift return to overplot, we can see that we got the last closed flex surface. Okay. We can also change, just as to recap kind of what we've done. I click on the select tool, click on the axis. I want to set the aspect, and I set that to be equal, for example. This will give me this. Okay. So this is to say that an equilibrium has a last closed black surface. So there is a tool in OMFIT that allows you to conveniently edit these last closed black surfaces. This is done through what was the name of it? Boundary.
There's an example in the regression test for test boundary shape.
Oh, boundary shape maybe.
That's capital B.
Boundary shape, yeah. So so this boundary shape class, if we look at the documentation, accepts all of the plasma parameters, or I guess more conveniently, a G file. So here we can say GQD SK equal, and we can take this G file, and we're gonna have an object from this class, and if we say this one dot plot, and we execute. This one generates this this interactive figure. So if we look at again, let me go under my command box. I have a TMP object. Okay, this TMP object is the result of the boundary shape, and by calling the plot method of this object, we get this. And from here, you can see how you can, for example, change the elongation of your plasma, or for example, the triangularity or the squareness of your plasma. And you can have something that maybe has both a lower and an upper null. And then you can take this and use it in other codes that maybe solve equilibrium for the U shape. I think this is it. So I'm gonna, at least for the plotting part. Well, no, actually, David is gonna tell us about styles, right?
Yeah, I'd be happy to.
So I'm gonna stop share. And I'm gonna get some water too. I'll be back.
Okay. I will tell you about plot styles now. If you take the command box here, make some XY data, and make a plot, by default, it'll look about like this. The text here is too small for a good presentation or publication. The font might not match your specifications, so you'll want to change it. You could do that by going to the plot menu and exploring this plot style tab here. There are some presets you can choose. For example, there's this D3D one. If you select that and then rerun the script, the plot now looks different. You can see the font and line widths have changed, etc. There are several different ones. For instance, this one's designed to fit in a paper where you have one of two columns, so it's tall and thin. It might look better if you had more subpanels too. Additionally, there is a style editor. This can help you modify or create your own style. There's an example plot at the top. For faster editing, you might want to disable the sample figure. You can see there are all these things that go in the matplotlib RC params dictionary. And as you scroll through, you can find these. You can pick one that you like. Let's look for figure.figsize. There it is. Add it. Now it's in here. And you can see it has its default value. I can change this to something else. And I could save a user style if I wanted to with a name. But I'm not going to do that. Now, if I plot it, it's a square. It wasn't before, now it is. You can also start from one of the preset styles instead of modifying from scratch. For example, I'll load this one. Now you can see all of the customizations that were made to this. The formatter limits are nice because that sets the exponent that you get to before it starts separating out the times 10 to the third or fifth down to the corner. You might want 1,000 instead of 1, and then at times 10 to the 3 over in the corner. This, it'll go to 10 to the 5 before it does that. And then there are other changes that you can perhaps understand if you read the text. If you want to go back to the default, you just go back and do reset to defaults. You can also use these in your scripts. If you want to load a style within the scope of only one figure and not globally, for example, if you're making a script to make an example figure and you want to reproduce it the same way every time, you can put this style.use in before you open the figure. And now that figure and just that figure will have this specified style. And if you run a script over here, it doesn't. It has a different style. So you can have each, if you have a set of example scripts in your project for making specific figures that you need, you can have each one have its own style if you don't want to enforce a global style. You can also customize after you've loaded it. So you can load a style and then you say, well, I want this, but just one change just for this figure. And you might want to change the figure size for only one figure. You can load the style and then you can modify it just a little bit. If you do more than a few lines, you might want to make a new style. Up to you. See, now it's really narrow. And that's how the style editor works. Excellent. Any questions? So you can use it from the top to set it globally. You can make your own styles and save them. And you can use it in the limited scope within a specific script. Now, while you're making figures, you may want to save them with a table of settings or some other printed text describing what the figure is and the context in which it was generated. For example, you can put a shot number on a figure, but you might want more than that. You might need a longer table describing settings in your simulation run. To do this, you might want to embed your generated figure in a LaTeX document to make a PDF with all the information together. And the best way to learn about how to do that is to open the scripts LaTeX folder within the tutorial module and run build LaTeX example. And if I do that, it is now generating a bunch of files. And now it's made a document. First, I'll show you what's in the document so you can get a sense of when you might want to actually do this. It's using a LaTeX article class, so you can put an abstract if you want to. You can put a title if you want to. You don't have to. You have enough freedom to really ruin your life with this. But if you copy an example and make small changes, you probably will be okay. So there's a figure embedded here. There's also a table of settings. This is just an example, so it was boring settings like what you'd find in an experiment. So shot, time, device. But you could also put in the settings for your simulation run, like what you set for the edge resonant parameter or how many time steps you ran for. And that could be essential for understanding the case shown in the figure. And of course, you can put references in there if you want to. Now let's look at the folder that made this. When I ran this script, it made this folder. It's OMFIT LaTeX. It acts a lot like an OMFIT tree, but it has more options. So it has these tech files in it. It has a bibliography file, and it has the output file. When you press enter on it, it opens its output. In addition to the OMFIT tree things, it has a build command. This builds the LaTeX thing. And if you need more control, you can open this thing. Then you can choose between a full build, which does PDF, LaTeX, and BibTeX, and then again. Or you can do a more limited scope. And if you use LaTeX, you'll know what that means and appreciate it. You can also dump the project files to another thing. And that's how that works. Any questions?
Cool.
It's almost like a write paper button.
Somebody wants to ask if OMFIT was going to write their papers for them.
This is the answer. With OMFIT LaTeX, it can. But I made this because I really needed to remember all the settings that went into my cases. Just making a stack of figures and trying to cram some footnote into them was just going to get out of control.
So it's auto-generating those tables that you showed with the settings?
No, I had to write a script to make that. That is this, make settings table. So I wrote this script. You have to prepare the scripts to make the text files you use. Once you've given a set of text files, it can assemble them and build them and call LaTeX for you. You could also do this on your own. You could make the text file, you could copy and paste your settings into it, and you could build it yourself. But that's too many steps for me, and I'm lazy. So I wanted OMFIT to just do that.
Mm-hmm.
If it can be scripted, it will save me time if I script it early.
Right. So then for future projects, you can probably just run the same script and it'll just parse your session. Almost automatically generate the table.
If you want really basic stuff like what's in your experiment settings, like shot time device, then yeah, you could just copy this and tweak it. But if you want something more complicated, you're going to have to write the template itself. I generated this as a long string, and I used .format to fill in the fields. So you can see it says shot, and then there's the shot field that Python fills in. And you'd have to make that yourself for your own module. You could do it on the module level, so you just do it once for the module.
You could also think of making something that automatically generates it for a flat, like for a dictionary, a table.
Yeah,
like table from dictionary.
You got a generic like OMFIT session, just set.
Yeah,
push out like all your OMFIT parameters, your 1-2 things.
Mm-hmm.
It's actually David has put together the cake module, consistent automatic kinetic EFITs. And in that module, he records all the settings for all of the kinetic EFIT part and the 1-2 part, the EFIT part, the profile.
The version
part.
of cake, the committed was on examples time slices for the profile fits, example time slices for the EFITs. Basically makes the kinetic EFIT work on its own. Okay, so to properly use it in its current form, you do have to think a bit, but there is an example and tutorials to go from to get you started.
Can you show? Can you open the OMFITbibtex script?
Yeah. Do you want me to run it, or
you can just open it. So OMFIT has this class for parsing. Oops, is it there? Can you make it bigger? OMFIT has this class called OMFITbibtex for parsing bibtex files, and not only does the parsing, but it can do some useful things for you. So it can look up for the DOI, which is the string that you need, like the unique string. So it will connect to a database, and
And then we'll populate everything.
it will populate it. Yeah. And then it has a sanitize, script that for now doesn't do much, but it fixes authors, which are all caps, and fix the Unicode. Hold on.
you want me to change? Do you want me to zoom in?
Give me control.
You said you wanted to zoom in.
Okay.
Like my bibtex file is such a Frankenstein, just different things that I copy over.
I didn't know I could generate an entry from DOI with this thing. That's
So
awesome.
so if you go to let's see.
I have to keep her the DOIs.
If you go on
Wait, which does it do? Does it add the DOI, or does it take the DOI and fill in the rest?
I think it will do both. So if you, oh wow, why I don't have it? Oh no, oh because it's is it updated, Iris?
It looks like it.
Let me import the tutorial module again. Tutorial. So under scripts, LaTeX, no. Okay, I'll give you back the the ball, but stay still. No, so if you can maybe copy that script into the command box and see how it runs.
Or just run it. Is that
Yeah, you can.
legible there?
Yeah, you can either run the whole thing or go step by step as you go.
Yeah, we got an OMFITx.end. That's something we haven't gone over yet.
Oh yeah, can you add OMFITx.end before the DOI?
Here?
Yeah. So this is how you stop OMFIT script from going further.
You can also stop it like that, but that causes an exception.
That will raise an exception, correct. So if you look under OMFIT citations, I guess, this is a bibtex file, and if you look inside of it, there are 2 papers from OMFIT. And now if you try to run the DOI thing, so yeah, this will connect to a database and fetch the DOIs for these 2. Also, that's strange.
What's the score?
Okay. Yeah, it's okay. No, so the DOI is actually the DOI. So if you copy that and paste it, it will take you to the correct to the correct paper. Now you see that it filled in some entries. I don't know if you noticed. For example, it overwrote my name. Menegini there is all capital. So if you do this sanitize, it will sanitize the all caps and fix Unicodes. Well, yeah. I mean, you can just run the whole thing. Yeah, exactly. And actually, will raise an error.
Okay.
And then you can use this also to dump your citations into a format that you want. Yeah, this error got fixed. It's just that you haven't restarted your OMFIT session. Okay.
I started it.
Okay. Do we want to show some scripting? Let me do that.
What? Am I done?
Yeah. Okay. Share. So some of the scripts that we've shown have, or actually many of the scripts that we've shown have this thing called defaultVars at the very top. So if we look under, this is another regression script. Regression. I guess if I look for a default. So this script is supposed to test the default vars. So let me just run this. So if you look at the script like this, it has this this entry at the top, which basically sets some entries to some variables to a default value. Okay. So for example, tree is set to be OMFIT, file is this object, int is an integer, float and string. What we can do is then if you hit return on this script, it will just execute the script as is with these defaults. If you hit control return, it will show up these the things that are in default var. So it will run up to there, wait, and then we can change something. And then if you hit continue, the script will continue with that. Also, these variables are the variables, in fact, that you can pass to the script. So if you do .run, and if we say int a equal -1, and we execute it, this is something that we passed. If we pass something that doesn't exist, it is not in that default vars, it will raise an error. Okay, it says, this is unexpected. Okay. So this is often handy. If you know which script you want to run, maybe you don't have to start the whole GUI for a module to do it. This is kind of a more of a developer's thing. There's also a difference between running a script and running it. So here we're using run. There are kind of different flavors of run. Let's put a pause. Let's put a sleep. Let's sleep 2 seconds. So if we execute this script, you see that there is this graphical interface that is up. If we say run NoGUI, it runs it without an interface. Okay. Which this is useful when you're running a script. So let's see. Yeah, this is useful when you don't want the graphical interface to respond to a script being run. Okay, so not only the script doesn't show up in as the window, but also if we have a graphical interface open, it will not react to that. And maybe one more thing. I don't know how much to cover. Should we leave the prun or?
We could.
No, okay. Let's. Well, let me show you this. It's I think since we're covering the flavors of run, so as a regression test, if you look under prun,
No problem.
And let me just run this so that it sets up the whole thing and runs the test. So one way to run OMFIT scripts are in parallel. This is what prun stands for. And the idea is that you use this when you want to run the same script, but just with different input parameters, for example, in that default vars. Okay. And so the way this will look is we have a script. This is the serial script. It does some operations. Okay. And you want to run it in parallel, so we're gonna look at this parallel. So here in this case, we are taking a serial script. In this case, we're running 3 instances of this script, 2 of each in parallel. The output that we want to record from the serial script is this mult, data, and result2 variables that were in the serial script. So if you look here under the serial, there were some variables defined. So we said mult, data, and the result2. And to this script, we're gonna you see that it accepts in_s, and which should be an integer, but we're gonna pass it to the prun. We're gonna pass an array of 3. So each one of the instances is gonna get 0, 1, and 2. Okay, and then when we run this, we just call our parallel runs A, B, and C. So if you try running this, so you see A, B, and C, and then those blocks that pop up is each one of these scripts, being run, only 2 at a time, concurrently. And under A, B, and C, we get the result of that. Okay. Now you can daisy chain, or nest them. So if you want to do a parallel run of a parallel run, you can do that. And this is what this parallel outer script does. It's calling the inner parallel script, again, to be called in parallel. And so here, for example, the output of that script is this pouter 0, 1, 2. Each one with its own thing.
Are you actually launching additional thread?
Yes. correct.
So that seems a little dangerous.
To do parallel?
Yeah.
Yeah. So be careful.
That seems like a good way to block a machine.
So, but for example, we use this sometimes also for job submissions. There has been like recently some developments, for example, for submitting hundreds of Java jobs to a cluster. So you just, it's the same thing, just the parameter scan. You launch them later on, then you can get the data back later on.
Just as a suggestion, you may want to think of something other than parallel, because at some future point you may put parallelism in there. Where you're actually running, where you're actually launching a job, multiple processors.
You can do that, yeah. You could.
And so you may just get some conflict in terms of
nomenclature, parallel.
Yeah.
Yeah, kind of hard to change. But yeah,
Right.
Point
It's
taken.
a little bit it's a little misleading by calling it parallel. If you're, at least from my side, if you're a computationalist, I would just assume that it's a parallel job instead of it's actually multiplexing a serial job.
Yes, correct. Yes. Yeah.
So we should call it mrun instead of prun for
Yeah,
multiplexer.
maybe or something like that. I don't know.
Multi-run.
Multi-run, yeah. So if you want to, actually the prun is, I think, also in the tutorial module. If you are looking for something, you can look for it in OMFIT. You can click on this button. For example, if you're looking for pressure, okay? If I click here, you can look for something like press, okay. So I found this one, and then I can see if there is something else that has press in it, and so on and so forth. This is not only true for the entries in the tree, but you can also look for scripts that have that. So if I select, for example, the tutorial module, I search for, we said prun. And so here I found this, and then, but actually also the content of the script. So if I click on this one, it's going to show me where the prun word comes up. Okay, so I can, this is a way to search. Let's say that you rename a variable and you want to make sure that you renamed it in all of your scripts. This is how you do it. Now, if we're looking maybe something about remote operations. So OMFIT can interact with the remote servers. So if you have it set it up, which fundamentally boils down to setting up your username here. Here there is a list of servers which you may or may not have access to. But if you do, and your username is all set up right, you can right-click, say Remote X Terminal, and this will start your a session there. So you can be on Edison, you can be on Portal, or here, and this will also go through the tunnel for if the remote connection requires a tunnel, it will tunnel through. So this sometimes comes in handy. Other things that you can do remotely. Let's say that we want to grab a file that we have on Portal. So here, if you do edit tree entry, let's pick a file. And when we do open file, right now we are on Iris, but we can select Portal either from here or from here we can just type Portal. And this, will connect us remotely. And this is my, my hard drive at Princeton. And so here, if I go to OMFIT source, samples. Also, it has a tab completion. So if I say sa and then tab, it will tab complete it, and then I can look for let's say a state file.
This is all going to look at your base host files and your SSH files, your keys and things like that. Does it store it in a separate like OMFIT?
This this is using the way OMFIT it uses a private and public key for connecting remotely.
Right, but does it generate its own separate?
No, it uses your own. Yeah, correct.
So if I already have like my SSH key, it should already.
Yeah, correct. Okay. So now if we hit load, if we hit if we load it, this will move the file that I had in Princeton and move it here. It downloaded it in its own, the file name here is in this temporary folder, and we said that this is Netcdf, right? So where is it in Netcdf? So when we load it, this is a file that was previously on a different machine. If we want to upload it, we can take any file and we can say .deploy. I could type the file name and then use a server picker equal portal. And this will deploy it there. Or we can also say deploy GUI. And this, brings up the GUI, and we can say portal, and we can, we can save it with however name we want in that directory. We maybe not there. Just do it in my temporary folder. Okay. So this will, just ship it over. Other interesting thing that I think are pretty useful to do. Let's say that you can compare any two objects in OMFIT. So if we duplicate, for example, this G file, and or maybe let's do this. Well, it's okay. Let's do it on a G file. So let's change something here if we haven't done so yet. I think we may have already done.
I think you modified the pressure. Well, this is a good opportunity, right?
So we want to see if something has changed. Well, I deep copied it, so let me reload it. Let me reload it. Okay. So I just I think this should be the pristine G file. So if I right click on it on any two objects, here you can see compare merge entry. I can pick any other object, so in this case gfile1, and we can compare all the entries underneath to a certain relative precision. If we hit return, it will go through and compare everything. We changed something, and it was under flux surface average JT over R. Double click, and this is what we changed. This is, if you have two name lists, right? You ran two simulations, you don't know what's the difference. You can load them up and see the differences. And then you can selectively, bring one, the content of one to the other, kind of, merge between the two. If we select a spacebar, for example, this will take whatever is in. So here we're comparing G file to G file 1, and this one will be the final result in G file 1. So if we merge it, now G file 1 got updated to what the other was.
So it looked like it was using diff for the screen comparison.
No, it's own.
It's okay.
Yeah, you can compare also scripts. Like if you have two scripts.
So I'm wondering if you just change the different, or whatever different.
So well, it's comparing every key in the dictionary, and it's going through the hierarchy and see if things have changed.
So the Python thing, or
yeah, it's its own, yeah, Python. I guess it's yeah. If you,
I don't think we're using a library for it.
No. If we make a copy of this script and we change something in it, figure 2, we can delete something. That's something. So we can compare this one. Again, compare, and we're gonna compare with this one. and we can see what changed. Okay. Excuse me?
Yeah, I think it is using it. It
What?
looks like it's using it. It's for the string comparison.
For the
In which
string
case, I think you can change the diff engine.
for
So the only reason I know this is that when you do an SVN merge, it has a default diff engine that it uses, but you can switch it out. Sometimes you can do a little more granular comparison.
so for the strings, it's using a Python library for it's I think it's a standard, which is it's I think something which is in the standard Python library for it. Okay. And since we're over time already, I think what comes, what we thought we were going to cover too is not really critical. You can compare two entire projects, just use with caution depending on the size of the project. If you are with a project and you have another project and you say what's the difference, you can say compare to project, and it will compare every key in your project.